They found it near the edge of a dying star cluster, and PSR calls it something colder than a name, just a string of numbers. Right now, that neutron star is still spinning, still ticking off a clock that says it is older than the universe that supposedly made it. And the astrophysicists at Caltech have no way to explain how something can be older than time itself. What they found buried in its data is the part they don't want to put in the headline. Neutron stars are supposed to be simple math. A massive star dies, it collapses. What's left is a city-sized ball of pure neutron matter, spinning so fast it can lap itself hundreds of times a second. You measure the spin. You measure how fast the spin is slowing down, plug it into an equation. Out comes an age. Astronomers have used this trick for 50 years. It has never failed. Until this one. When the team ran the numbers on this particular pulsar, the equation didn't hand them a reasonable number. It handed them a number older than the Big Bang, not by a little, by billions of years past the edge of everything. The universe is 13.8 billion years old. This neutron star's internal clock said it had been spinning down for longer than that, longer than space itself has existed, longer than time in any sense we use the word has been running. The first move was to blame the instruments, recalibrate, rerun, check for a decimal error, a bad filter, a corrupted dataset. Nothing changed. The second move was to blame the star itself. Maybe it was recycled, spun back up by a companion star feeding it matter which can throw the simple aging formula off by a lot. That explanation works for some pulsars. It didn't work for this one. Its companion is gone. Its spin history doesn't match a recycling event. The clock still says impossible. Here's where it gets uncomfortable. That spin-down age isn't just a rough guess. It's built on the same physics that gives us GPS satellites, gravitational wave detections, the timing of pulsars used to map the entire galaxy. If the equation is wrong here, it might be wrong everywhere quietly for decades. And if the equation is right, then something about this neutron star's birth doesn't fit inside cosmic history at all. Either way, someone at Caltech has to explain a number that shouldn't exist, and right now, nobody can. But that's not even the part that worries them. Buried in the follow-up data, the team found something stranger than the age problem itself. The star's magnetic field is decaying at a rate that doesn't match its spin-down at all. Two properties that are supposed to move together, locked in step by the same physics, decoupled. As if two different clocks are running inside the same object, disagreeing with each other, and both disagreeing with the age of the cosmos. One researcher, off the record, called it a neutron star that doesn't know what year it is. There's a darker read floating around the preprint servers, one nobody wants to say on camera. If the spin-down age is even partially accurate, this neutron star's progenitor star would have needed to form and die before the standard timeline allows stars to exist at all. That would mean either the early universe made massive stars faster than any model predicts, the same tension already cracking open with JWST's impossible early galaxies, or this object isn't a normal neutron star born the normal way. Some are quietly floating a third option, that it isn't from this universe's clock at all, that some relic process, a primordial collapse, a leftover from conditions we don't have a name for, reset its physics before galaxies had even finished forming. Every explanation on the table requires breaking something. Break the aging formula, and pulsar physics gets shakier everywhere it's used. Break the early universe timeline, and star formation models need a rewrite. Break neither, and you're left with an object whose internal clock simply refuses to agree with the age of everything around it. NASA hasn't issued a statement. Caltech hasn't walked it back. The paper sits there, technically published, practically radioactive, and it's still spinning, still ticking off that impossible number, second by second, indifferent to which explanation we eventually choose to believe. So if a dead star's own clock says it existed before time did, what does that mean for the clock we're all using to measure everything else? Tell me what you think it's hiding down in the comments.